Okay, welcome back. This is section 1.2, angle relationships and similar triangles. Your objectives for this section will be I will find angle measures, and the second one I will find angle measures and side lengths in similar triangles. We do lovingly get into word problems there at the end. So on the first one, angle relations similar triangles, we start with our vertical angles. This is something you should remember from way back in geometry, Cambridge, whichever you came from. Angles that are across from each other. Vertical angles have equal measure. So if we were looking at any particular angle, then what we would have, let's use blue today. This angle here would be congruent to this angle here, or this angle would be congruent to this angle. This is one of the things that we get to watch for. So if parallel lines are cut by a transversal, again, this is stuff that you would learn way back in geometry or whatever, then we have alternate interior angles are equal. Our alternate interior angles are going to be on the inside, but they're going to alternate over this transversal. So your red line here is your transversal, and this here is going to be your parallel lines. So if we went through and listed all of them, they don't ask us to, but if we listed them all, then it would be 3 and 5 are alternate interior angles, and then 4 and 6 would be alternate interior angles. Alternate exterior angles are also equal, and the exterior angles are on the outside. So 1 and 7, because they alternate over the sides of the transversal. 1 and 7 are alternate exterior angles, and 2 and 8 are alternate exterior angles. Same side interior angles add up to 180, that is these two here. Angle 4 and angle 5, notice this is obtuse and this one is acute. Together they'll add up to 180, and together these two will add up to 180 as well. Same side exterior angles also will add up to 180. So exterior is going to be the 8 and the 1, they're referring to the same side of the transversal. So 1 and 8 are going to be adding up to 180 or supplementary, and 2 and 7 would be supplementary to each other. Corresponding angles are also equal. Now the question is whether or not you remember what these corresponding angles. But the corresponding angle, it would be angle 1 and angle 5. Notice that they're both obtuse, so it's a little bit easier to see this. The corresponding angle is on the same side of the transversal, just on different parallel lines, but they're in the same spot. So you have your transversal 1 and 5. 1 is above the parallel line, 5 is above the parallel line on the same side. So that would mean 4 and 8 are also corresponding angles. 2 and 6 and 3 and 7 are also corresponding angles. Okay, on the next one, they're asking you to find the measure of each marked angle. Let me underline that, marked angle. That's what you're looking for, not just the value of x. And then they say the lines M and N are parallel, so that's going to get us down to this one here. So on this one here, we have vertical angles, and vertical angles are congruent. So we know that all we have to do is set these equal. 11x minus 37 equals 7x plus 27. Go ahead and pause this at this point, work through your problem, see if you get the same value of x as I do. And if you do, then you know that you're going to be in a good shape to get those angles. Once you have one, you should have the other. Okay, so we'll come back and we'll look at these. If I subtract 7x from both sides, subtract 7x from both sides, we get 4x minus 37 equals 27. add 37 to both sides. We're going to get 4x equals 64. Divide by 4, and we get x equals 16. Now remember, this is not the answer we're looking for, but if this was a test question, you got x equals 16, you'd at least get partial credit, but you had not answered the question. Always make sure you go back and reread the question. You were looking for the measure of the marked angle, not the value of x. So since we know these are congruent, we do one, all you have to do is double check the other one if you really wanted to. So 11 times 16 minus 37 is going to be, if I do my math right, 176 minus 37. This is, of course, where I get the calculator, make sure I did my math right. And then we subtract 37, and we get 139. And since they're vertical angles, both angles should be 139. And we can always double check by either setting this equal to 139 and making sure we get 16 for x, or you can simply put 16 in and make sure you get 139. I'll let you guys do that double check. Okay, on the second one, this one here, we now have parallel lines cut by a transversal. So we must first identify what the relationship is between these two angles. And they are alternate exterior angles. And alternate exterior angles are congruent. So again, all we have to do is set these two equal to each other and solve. So I'm going to ask you to pause at this point and you set up the problem, go through at least find the value of x before you come back and see what we're doing here. Okay, welcome back, and let's finish this one up. So I have 6x minus 51 must equal 2x plus 61. Subtract the 6x, subtract the 6x. I'm going to double dip on this one. I'm going to also add 51 at the same time, just to save a step. I'm not really saving a step, I'm just doing two at once. So I really don't, well, I already started this. I would not have normally done this. I would have subtracted the 2x. Don't ask me. Oh, this is just wrong. We're going to backtrack, and I apologize. I don't like how I started this problem. So we're going to erase this and try it again. We're going to subtract 2x, subtract 2x, and add the 51. That was just bad on my part. And until I learn how to edit these things, you guys have to deal with the mistakes. Sorry. All right, 4x. These two guys cancel out, equals. These two guys cancel out, and we get here 112, unless I did my math wrong. Divide both sides by 4, divide both sides by 4, and this is where I grab that calculator, double check my math. You know, nothing's worse than having that wrong. Divide by 4, and we get a 28. So x equals 28, but that's not what we're looking for. We're looking for the values of these angles. And since they are the same, they're congruent, we know that their measures must be the same. So all we have to do is one, you double check using the other. So I have 6 times 28 minus 51, and 6 times 28 is 168 minus 51. So subtract the 51, and we get 117 degrees. There is the measure of our two angles. I will let you double check the 2x plus 61. Obviously, if you do, pause. But do check it. Make sure, check my math, even though, we all know I'm right. Do check my math. Okay, so let's go into a triangle now. Now we're at the full-fledged triangle. And we have the sum of the measures of the angles of any triangle is 180 degrees. So, what I need you guys to do is remember this. This is another geometry thing, is that 3 angles in a triangle always, 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 always add up to 180 degrees. So on this one, let's find the measure of each marked angle. Well, they marked all 3, so I guess we're finding all 3 angles. Which means on this one that the sum of the 3 must add up. So what we have is 2x plus 16 plus 3x minus 6 plus 5x minus 50. All of these together must equal 180. So we do our math. 16 minus 6 is 10, and then 10 minus 50 is going to give us negative 40. And 5 plus 3 is 8, plus 2 is 10. So I have 10x minus 40 equals 180. Now, you may consider this cheating, but I have a 0 at the end of all of these. So if you have a 0, no decimals, not after a decimal, just before, you can just simply cross them out. So you really have x minus 4 equals 18. So x must be, add 4 to both sides, sorry, plus 4, plus 4. X must be 22. Okay, we got our value of x. Now what we have to do is find the value of each of our angles. So, this one. 2 times 22 plus 16 gives us 44 plus 16, which gives us 60. There's one of my angles. Don't forget those degree symbols. I know I'm being bad. Now, the next one, 3 times 22 minus 6 equals 66 minus 6, which is 60. So now we have 60 and 60, we have 180 left, which means this one here must also equal 60 degrees. Because if we do our quick little math, 60 times 3 equals 180. Or you could have simply done 60 plus 60 equals 120, and 180 minus 120 equals 60. So there's the work for the last one. Or you could have just done the math and double checked yourself. Okay, so I'm going to try and make sure that you guys can see where I'm going. This is the first bit of math, and then the first angle, the second angle, and the third one. So this is where I checked this one. This is where I did the math for this one. And this is where I did the math for that one. Okay, next question. Again, they're asking you to do these. Now this is where I get to ask you if you remember what about the remote interior angles. Another theorem from geometry that says these two angles, the interior angles, these two angles would be equal to this one here. Now, if you think of supplementary, it kind of makes sense, but we're not really working with supplementary, kind of, sort of. But these two angles have to add up to 180 because it's a line. A line is 180 degrees. These two must add up to 180. And the 3 angles in a triangle must add up to 180. So this is where the remote interior angles theorem comes from, is that these two must be the same as this guy here, since this guy is supplementary to the third angle, and all 3 angles must add up to 180. So you can do this one or two ways, is you can find this other angle and then do supplementary, or just simply use remote interior angles, which tells us that the negative 5x plus the negative 8x plus 3 must equal 7 minus 12x. That is the remote interior angles. I am not going to do it the other way. You have a question on it, you're going to throw it on your paper going question mark, and you're going to ask me this tomorrow. Okay, so 5x and 8x is going to give me a negative 13x plus 3 equals 7 minus 12x. Now I'm going to throw this out there to you guys. I really like my x's on this side, but I don't like playing with negatives either. So I'm going to move this guy over here. That way I have my positive. So plus 13x plus 13x. And then I'm going to move this guy to this side. Minus 7, minus 7. So these guys cancel out, and I've got 3 minus 7, which is negative 4, equals, and these two guys cancel out, and 13 minus 12 is 1x. So x equals negative 4. This is okay. If you're going, wait, I can't have a negative number. Sure you can. X is negative 4. My 5 here is negative, my 8 here is negative, and this 12 is negative, which now is going to give me positive values. So this angle first, negative 5 times negative 4 gives me 20. And negative 8 times negative 4 plus 3 gives me 32 plus 3, which is equal to 35. And since this one is the sum of the two, according to this guy here, then it's 20 plus 35 is this guy here, which is 55. Now, yes, you could have thrown the negative 4 over here and got the answer the same way. But there's the answer to the last one. There. This one goes to that one, and this one goes to that one. Should have made you guys work that one out on your own, but hey, we did it this way. Okay, how are we doing? I am about 18 minutes into the video, so we're going to continue on doing this one. I have to break this video into 2 days only, so we might go a little more than 25-30 minutes. I've right now got it planned for 20. Okay, this last one, oh, look at this. They threw in degrees, minutes, and seconds. It says the measures of 2 angles of a triangle are given. Find the measure of the third angle. Well, we still know they add up to 180. So you're going to have to use some of that information you learned in section 1.1. So we add the 2 angles together. So I'm going to just bring this guy below. So 96 degrees, 12 minutes, and 10 seconds. Gives me 96 plus 17, because I really want to make sure I don't make mistakes. Gives me 113 degrees. 41 and 12 gives me 53 minutes. And 13 and 10 gives me 23 seconds. Now, the 3 angles, so 2 of them, we have the 2 of them. Remember, in a triangle, they add up to 180 degrees. So we have to take 180 degrees, 0 minutes, 0 seconds, and subtract 113 degrees, 53 minutes, and 23 seconds from it. So we have to borrow, but this is where you need to remember this one little bitty information. 1 degree is 60 minutes, so I take 1 degree off of this, 179, and now I have 60 minutes. And then remember, 60 minutes is, 1 minute is 60 seconds. So I take 1 minute off, so I've got 59 minutes, and I get 60 seconds. Now we can do our math. 60 minus 23 gives us 37 seconds. 59 minus 53 will give us 6 minutes. And 9 minus 3 is 6, so I get 66 degrees, 6 minutes, and 37 seconds would be my third angle. Now, another thing that students have done that I've seen them do is that they'll change everything to decimals, do all the math in decimals, and then convert back to degrees. You can do it that way, or degrees, minutes, seconds. You can do it that way, but it's a little bit longer route to go. Okay, I'm going to pause this for a second just to see how much more we got to go. I'm at 20 minutes, so I'm going to pause. Okay, I see about a little bit more we can do, and then I'll pause it for the day. Types of triangles. We're going to do the types of triangles, any examples, and then we're going to call it a day. Okay, angles, the different ones you can have are acute, right, and obtuse triangle. So our angles, the type of triangles, now remember, so acute triangle means all of the angles are acute or less than 90. A right triangle is one angle is right, the other two are acute. You cannot have a 90-degree angle and a 150-degree angle in the same triangle. It just doesn't work that way. And an obtuse triangle is one angle is obtuse, the other two are acute. So that's what we have. If it's by a side name, you have an equilateral triangle. Equilaterals, all sides are equal, which means all angles are equal as well. Isosceles triangle gives us two sides are equal, which means we have two angles are equal. And a scalene triangle is no sides are equal, which means no angles are equal. Now I do want to go back to this equilateral triangle. An equilateral triangle, you have it's also called an equal angular, but we're not going to go there. I'm just giving you guys a little tidbit more of information. So there you guys go. So in the next couple problems, we're going to ask you to identify your triangles by angles and sides. So here we go. We classify each triangle given the lengths of the sides and or the measures of the angles. So if I have 120 degrees, that one is more than 90. So it's obtuse. So I'll write it on here. 120 is greater than 90, so it's obtuse. And our sides are all different, so it is scalene. All right, so this one, 130, again, 130 is greater than 90, so it's obtuse again. But two sides are the same, so we get isosceles. Okay, pause it for a second and do this last one and see if you get it right. Remember, you have to classify it by the side and the angles. Okay, 90 degrees is 90, so it's a right triangle. Now I know it doesn't say anything about the sides, but it does give you two angles. One is 90, one is 60, which only leaves 30 to be the last one, and if the three sides or angles are different, then the three sides also must be different. So this one would be scalene as well. How'd you do? Okay, I think this is about where we're going to leave off for today. So 24-minute video, you guys probably watch it for about 30 minutes or so. This should be good for you. All right, and we will do part 2 tomorrow.